Yes, hi, this is George Darekis again, and today I would like to continue with some examples in convergence or divergence of series. So, the first example is to find if the series sigma from n is equal to 2 to infinity square root of n over n minus 1, if it's converging or diverging. According to the tips that I gave in my previous video in the same subject, this series here is non-alternating. So, as I said in my previous video, the first thing you check is if it's a geometric series, is not. If it's a p-series, is not. So then we have what? We have the integral test, the comparison test, and the limit comparison test. Integral, I don't think so that it's easy to calculate this integral here, or even if you can calculate it. So, but what you can see that, so what is left is the comparison test. So, and indeed, we have that the square root of n over n minus 1 is greater than the square root of n over n, because this here has a smaller denominator. First, if you cancel the square root, this here is equal with 1 over n in the 1/2. So this is a p series with p equal with 1/2, and because p is less than 1, that's a diverging series. So this here is a diverging series. So that means that this here, which is greater than this, is also a diverging series. Now, example number 2 is to find if the series from n is equal with 1 to infinity, brackets n squared plus 1 over 2n squared plus 1, and all to the n, it converges or diverges. Here, since we have this n, first of all, again, this is non-alternating series. So again, it's not a p series, it's not a geometric series. It's very easy to verify these things. So, and because you have this n here, so that refers to the root test, to the nth root test. So if you take the limit of the nth root of this function here, you see that this limit is 1/2, so this is less than 1, so that means that this series here is absolutely converging. And example number 3, you have to see if the series from n is equal with 1 to infinity, minus 3 to the n to the third, if it's converging or diverging. So here we see this is an alternating series because you have this minus here. So, now here, again, this is not a p series, it's not a geometric series. You can do the integral test. So now what you have to check? You have to check if the absolute value. If the absolute value of this function is converging or diverging, so this is the absolute value. So, and actually the best test to take here is to take the ratio test. So if you take the 3 to the n plus 1 over n plus 1 to the third over 3 to the n over n to the third, so which is the n plus 1 over an. So if you cross out the 3's, you're only left with the 3 here, and then n to the third over n plus 1 to the third. So that is equal with 3n to the third, and this here becomes n to the third plus 2n squared plus 3n squared, plus 3n plus 1, and the limit of this, again, as n goes to infinity, is 3, which is greater than 1. So that means that this series here diverges. So thank you for taking the time to view this video, and I hope you find it useful, and bye for now.